Hello everyone, my name is Prashant Mungtani and with me is Ling Tang, and we're here to talk about working with rasters and imagery in the Pro SDK for .NET. I hope everybody's having a good developer summit. So let's start with a brief overview. We'll spend a few slides summarizing what's available in the SDK today when you're working with rasters and imagery, and then we'll dive straight into demos and look at code as to how you can use all this functionality in samples. I'll give you some helpful links where you can get more information about the stuff we talk about today. We'll summarize everything we talked about, and then we'll take questions. So let's dive straight in. The first section of the raster and imagery support in the ArcGIS Pro SDK for .NET can be thought of as visualizing raster data. Just like in the software, when you want to visualize raster data, you start by adding it to the map, which basically is the process of creating a layer from that data. So the layer factory.createLayer method allows you to do that within your code. You can create layers from 3 different kinds of raster data. An image or disk in a geodatabase, which results in a raster layer. A mosaic dataset, which is our data management model for managing collections of imagery, which results in a mosaic layer. And an image service from your ArcGIS server, which results in an image service layer. Now, both the raster and the image service layer are pretty straightforward layers, but the mosaic layer is a kind of a special case because it's a group layer containing 3 different sublayers. It's got a boundary layer, a footprint layer, and an image layer, which are all 3 sublayers of the mosaic dataset. I'm not going to spend too much time explaining what a mosaic dataset is, but we'll take a look at it in one of our samples. Now, on all these different types of layers, you can control how the data is visualized, and you do that by getting and setting a colorizer. So colorizers are the method in which the data is visualized. They have multiple properties which you can set in the UI using our appearance tab and the rendering section. We'll talk about colorizers in a little more detail in just a bit. At Pro 2.0, we added the ability to get to a more finer grained API. We added a new getRaster method on all our layers. And we'll talk about rasters and what they are in later slides. Now, mosaics and image service layers are special in terms of they have some additional properties. Both are mosaicing images on the fly. So the additional properties are usually related to how they mosaic the imagery and how much imagery gets transmitted. So you have additional properties such as the mosaic method, which defines the sorting of the images that are being mosaiced, and the mosaic operator, which resolves overlaps between the different items in your mosaic. You also have the ability to get and set compression method and quality, and that makes a big difference when you're working with image service layers and transmitting a lot of data. Last but not least, we have the ability to get and set processing templates. So both mosaic datasets and image services have the ability to carry along processing templates, which allow the user to process their result or output in different ways. And you can get and set these on both mosaics and image service layers as well. Now, when working with colorizers, especially when setting new colorizers on existing layers, we found that the colorizer object was a little hard to work with because it had so many properties. So what we did at Pro 2.0 is we introduced the concept of a colorizer definition. What this is basically just a simple representation of a colorizer with most commonly used properties, which is easier to set up than filling out all the properties in your new colorizer object. You can use a default constructor or customize the commonly used properties when you create a colorizer definition. You can then either create a new colorizer based on the colorizer definition, or you can create a new raster layer with a defined colorizer definition as well. Now we have colorizer definitions for each of the colorizers in the system that we support. These are just a few of them right here: the stretch, discrete, classify, etc. Now what you're looking at here is the symbology button that appears on our appearance tab, which is a contextual tab which appears whenever you select one of our either the raster, the mosaic, or the image service layers. Now this basically tells you what all colorizers can be applied to the layer or the data that's being rendered by the layer. Now in code, if you want to do the same thing, we have a new method on the layer that gets applicable colorizers for that kind of data. So that's basically visualizing raster data. That can be considered as a coarse grain API, which allows you to work with layers and how they're displayed. At 2.0, we introduced a more finer grained API in the form of core objects to work with raster data. So this allows you to basically access a access rasters without actually creating a layer from them, and more importantly, access their properties and, of course, pixels. So the first few objects that we added were a raster dataset object. Now, if you worked with ArcObjects before, you're probably familiar with the raster dataset and the raster bands. A raster dataset represents an image in either on disk or in a geodatabase. The raster dataset object supports, of course, getting the properties of the raster dataset, or you can also think of the raster dataset as a collection of bands. So you can work with individual bands by getting bands and getting properties for bands using the raster band and the raster band definition objects. The raster dataset definition object basically contains a lot of the properties for the raster dataset, and that's how you get these properties. Last but not least, the raster dataset object also has the ability to create a raster. Now this we'll talk about in the next slide in just a second. So you can think of the raster dataset as mostly a read-only object. So you open a raster dataset, represents an image on disk or in geodatabase. But what if I want to now change some of the properties or the pixels of the raster dataset? You do that by creating a raster object. Raster object is just an in-memory representation of your raster dataset. What that means is you can change things, you can tweak things, you can see how things look if you change them without making any changes to the actual image on disk. So that's why the raster object has more capabilities, such as not only getting but setting properties such as pixel type, extent, spatial reference. You also have the ability to get bands and work with those as well. But the additional capabilities you get with the raster object is the ability to transform points from pixel to map and vice versa. This comes in handy when you're working with geometry that's in the map, and if you want to translate those points into pixels. And we'll see an illustration of that in one of our samples today. If you want access to pixels, we have the ability to, the raster object gives you the ability to create a pixel block, then read pixels from it, do some things to them, and then write them back. Or we also have the ability to erase a pixel block as well. Now, if you're reading pixels from an image in the form of pixel blocks or blocks of pixels, we've given you an easier way to do that if you're doing it for the whole image or even a part of the image. The raster object has the ability to create a cursor, which is basically a raster cursor object. What this does is basically allow you to create, define the size of the pixel block that you want to read, and you can then read simultaneous pixel blocks from your raster until you reach the end. You don't have to worry about whether I'm at the end of the row, or end of the column, or if I'm at the end of the raster. The raster cursor takes care of all that for you. Last but not least, once you made all your changes, you can then use the save as method to save the raster out as a different raster dataset or a different image. Now, let's talk about the pixel block a little bit. The pixel block object just represents a block of pixels. So from there, you can get and set an array of pixel data if you want. But you also have the ability to get and set no data. So no data is handled in terms of either a value, but it's also stored as a mask along with your pixel block. So it's easy for you to A, find out if you have any no data in your pixel block using a simple method, or B, if you're doing per pixel checks, the bit mask is a much easier way or much faster way to know if your current pixel is a valid pixel or if it's no data or not. So that was a brief summary of what's available in the ArcGIS Pro SDK if you want to work with rasters and imagery. Now let's dive straight into samples and code, and we'll show you what you can do with all these things. So first up, Ling is going to talk about the new colorizer definitions and how they make it easier for you to work with colorizers.
Okay, Prashant. So for this first add-in, I'm going to show how to simplify workflow when you want to customize your colorizer and apply it to the layer. So now I'm going to show how the sample does. First, I select the layer. Then in the background, this combo box will call the get applicable colorizer definition, colorizer from the layer. So now this layer hook up with 5 different colorizers. And in the background, I customize those colorizers using the colorizer definition. So now I switch to stretch colorizer. So it will apply a set of properties from the stretch colorizer definition and apply it to the layer. So let's go to see how the code does in the background. So I'm going to choose another colorizer. For example, the classify colorizer, which is to classify your colors into different classes. Now when the onSelection change event got fired, now I'm going to switch my colorizer. I just selected the classify colorizer, so it will switch to the case where the raster colorizer type is the classify colorizer. Then I will call the method I defined called set2classify colorizer onto the basic raster layer. Let's go inside to see what this function does. In this set2classify colorizer method, first I define a set of parameters that I want to pass to the custom colorizer. I define the field name, the classification method, and also how many classes I want to classify, and also the color ramp to render this layer. And then now I'm going to define a new colorizer definition. It's called a classify colorizer definition. And in this new colorizer definition, we pass the parameters I just set as arguments to the classify colorizer definition. And then I create a new colorizer based on this colorizer definition. And finally, I apply this new customized colorizer onto my layer. Now I'm going to show it rendered with the classify colorizer. So in these simple ways, we pass a set of parameters into the colorizer definition and then create a customized colorizer based on the defined set of parameters, and then we apply it to the layer. So this is a simple way for doing that. You're working with changing your colorizers through the colorizer definition. Yeah, that's for this sample. Go back to question.
Thanks, Ling. So that was a simple example of how easy it is to use colorizer definitions. Next up, let's talk about those special properties of the Mosaic dataset, and we'll take a look at a sample which might be useful in the real world as well. So I have a Mosaic dataset, and a Mosaic dataset is basically a collection of images. So I have here about 25-ish images, and the Mosaic dataset layer, as I said, is a special kind of layer because it's a group layer, which has 3 different sublayers: a boundary layer, a footprint layer, and an image sublayer. So I can turn off my footprint layer. The footprint layer shows me all the different images in my Mosaic, or I can turn off my image as well. Now, when I'm working with large collections of imagery, this is a relatively small one. We have services that have Landsat imagery of the world over multiple years. So when I'm working with larger collections of imagery, what I want to do is to be able to focus on my area of interest and only see or only render the area of interest that I'm looking at. So normally what I would do is do that by selecting my image or my multiple images and say lock to my selection. So what the lock does is basically only render the images that are selected. Now I can see the other images alongside it as well, because my selection actually selected 2 images, one of which was my overview image, which basically covers all the area that's defined in the mosaic dataset. So you can see that if I show you the selection, it shows you I have selected an overview as well. How do I know it's an overview? The category field tells me it's an overview. So now I actually don't want to see my overview. I just want to see the image that I selected. So in order to do that, I will go back and say deselect my overview, and then go and say lock to selection again. And now basically I've done this. But if I'm moving across an area and I want to do this for the next image, I'm going to have the same problem, right? I'm going to have to go say deselect overview again and lock to selected raster again. So we created an add-in to make this process a lot simpler. Let me reset my lock. So I'm back to my original mosaic dataset. Let me clear all my selections. So what this add-in does is it basically locks to any raster that I select in the mosaic layer. So once I turn it on, I make sure I've got my mosaic layer selected. And now whenever I make a selection, it should lock to the selection. But I have the same problem. I have an overview in my selection as well, which I can't really avoid selecting. So then I say deselect overviews. And now I've reduced my workflow to basically a selection and a click. So let's take a quick look at how this works in the back end. And then we can talk about, or we can actually modify it so that I can simplify my workflow even easier, so that if I just select an image, I see it without having to go and deselect my overviews. So I'm going to go back to the code, enable my breakpoints, and make a new selection. So whenever I change selection on my layer, what happens is I've got an event handler for map selection changes. This event gets fired whether I make a selection either in the map or even in the attribute table as well. So once this event gets fired, I'm doing some basic checks to see if I actually even have an active map view. And what this event also gives me is a list of all the layers in the map that have selections on them and a list of the items that are selected. So I'm going through each map member, which is basically a layer with a selection on it, and I'm going to check certain things. First thing I'm checking for is that whether the item that has a selection on it is part of my mosaic layer, and if it's called footprint. If I have a selection on the boundary sublayer, I don't care about it. Next up, I'm going to also check if I've got a layer selected in the TOC. Then I'm going to check if that layer is the same as the parent of the footprint layer. Basically, I only want this to work if I have the tool on and the sublayer that has a selection to be part of the selected layer in the TOC. Once all my checks are satisfied, what I'm going to do is just set a mosaic method. I do that in my set mosaic rule function. What I'm doing is getting the mosaic method from the mosaic dataset. I'm changing the mosaic method to be lock raster. I'm taking the list of selected items, which is basically a list of selected object IDs. I'm creating a comma delimited string out of it and setting that on my new mosaic rule. So the mosaic rule is the object that contains all the different properties that I talked about that are specific to the mosaic dataset and the image service, namely the mosaic method, the mosaic operator, which resolves overlaps, the compression method and quality, and the processing templates. All that are encapsulated by the mosaic rule object. So now I'm doing something additional here in terms of, because I'm changing the mosaic method, when I turn off the tool, the mosaic method remains the same, as in my items are still locked. But I don't want that. When I turn off the tool, what I want is my mosaic to go back to the original way it was before I turned the tool on. So I'm actually storing the original mosaic rule and then creating a new mosaic rule because I want to still apply my lock raster mosaic method. So once all that is done, basically what happens is I lock to those selected rasters. So now what I'm going to do is add some code in here to basically look at my selection, look at all the rows in my selection, and exclude any rows that are overviews. I'm going to add that code when I'm setting the mosaic rule itself. But I'm going to start by creating a new Boolean to control whether I want to exclude my overviews or not. I'm going to initialize it so that it always starts off as being true. And now to save some time, I'm going to copy paste some code. So what this piece of code does, function. So what this piece of code does is check if my exclude overviews flag is set to true. If it is, I'm getting all the selected rows from the layer that has a selection on it. So I'm getting a selection, I'm getting all the rows in the form of a row cursor. I'm going through each row. And remember that category field I showed you? So I'm going to get the value of the category field for each row. And since it's an integer, I'm going to check if the category is not 2, because 2 equal to overview. And if the category is not 2, which means my row or my item is not an overview, I'm going to get the value of the object ID field. And I'm going to create a comma delimited string out of those. That's basically what this piece of code does. And now, when I am setting which object IDs I want to log to, I'm going to once again check if I want to exclude overviews. And if I do, I want to use the new object ID string that I just created in my new piece of code. So in a few easy steps, I have reduced my workload to be as simple as just selecting. So once Pro starts up, we can go through our new piece of code. Select my layer in the TOC, turn my tool on, and now I can make a selection. My event handler gets fired. Let's skip that part. And now here my exclude overviews flag was on. So what I'm doing is I'm getting the number of selected rows. I call the move next function on the row cursor, and I'm getting the tag. The tag in this case is 1. Because it's not 2, I just added that object ID to my string of object IDs. Now if we skip over to where we actually set it, you see that I have 4 items which are not overviews. And now I just reduced my workflow to be as simple as whatever item I select, I'm locking to. So now I can continue with my workflow by selecting my item, doing something with it, moving to the next item, select that, and working with it. So that was a brief sample on how to use the Mosaic dataset layer properties to lock to selected rasters. Next up, Ling is going to talk about how to do easy statistical analysis of scientific data using an image service.
Okay, so we just talked about the visualization of the raster. Now we move to process those raster, process raster. So the data shoot here is multidimensional scientific data. This is the wind speed over the Great Lakes area and the surface wind speed. So go to the attribute table. You are going to find they have a variable field which indicates which variable they have, and also they have dimensions, the time dimension. Some data also come with vertical dimension, for example, the soil moisture with different layers of data. So this kind of multi-dimensional scientific data, I'm going to tell the simple way how to do the statistical analysis of this data. Let me close it first. So select the layer, and then you put your definition query. This is, you can build your definition query through the layer properties, the definition query builder, or you can just copy paste the string here. It's basically it's the SQL expression. Expression, yeah. And we can edit the definition query here, edit the time. Also, you can add the variable name and change different variables. Now we're going to apply different operations. This, we have the mean, standard deviation, some basic statistical analysis. I'm going to apply mean here. So in the background, basically, it hooks up with a Rust function template. And this Rust function template, let me open it to take a look. It calls the Rust function called sales statistics. This sales statistic comes with different operations here. So it has the mean, standard deviation, maximum, minimum. And also, in the properties page, we have the definition query box. And so you put a definition query here, and you are passed to the Rust function template, and then you apply to layer to get definition query. So we simplify this workflow by just 2 clicks, then you can get your results. So let me walk you through the code to see. Now I'm going to switch to a different operation. For example, the standard deviation. After the onSelection change event gets fired, now I'm going to call a function called a custom Rust function template XML file. If you have experience working with Rust function template, basically it's the XML file. And I'm going to pass through the user-defined operation and also the definition query string into the XML file and add to some editing to this file. Let me go through this one. Now inside this function, we first search for the ID 8, find the node, and we're going to edit in this node. Let me open this XML file, take a look. This ID 8 is essentially the operation. So we're going to change the value here. The default value here is the mean. So I'm going to change to the standard deviation. So now my operation ID is 54, which is the standard deviation. I pass this value to my inner text to change the 40 into 50 into 54. And then I pass my user-defined definition query string into the Rust function template definition, which is over here is the load for definition. So I just pass the string over here. And now I'm going to apply this new Rust function template, actually it's a customized Rust function template, onto my layer. Inside this function, first I create a new theme rendering lure. And then I'm going to set this XML file as the Rust function template onto the definition of this rendering lure. And then I'm going to set this rendering lure onto my selected layer. So now the operation will be changed to standard deviation. So in this simple one definition query box and also a operation combo box, we can finish the workflow for like you apply the Rust function template and make changes inside editing and then apply the definition query onto the layer. Yeah, that's my demo for this one.
So that was another example of how you can save a lot of time by using simple add-ins that basically allow you to do a little more complex, something more complex in the background. So let's talk about the finer grained API now, and we'll talk about a sample called Mask Raster that uses the raster dataset and the raster objects that we talked about before. So the use case I have here is that I have an image which I want to share with another user. The problem is I want to be able to mask out certain areas of the image because one reason is they might be sensitive. The other reason is I may not want certain things in the image to be seen by everybody I share it with. So the add-in basically is pretty simple. I select the layer which I want to mask out an area from, activate the tool, which is basically a rectangle tool. Now, for example, let's say I want to mask out these 4 buildings. What I'm going to do is draw a rectangle around them. And once I finish my rectangle, because I don't want to change the pixels in the original image, I'm saving a copy of that image into my project folder by default. And then I'm going to go in and mask out the area that I selected. So my new image basically has an area with all 0 pixels in the, inside the rectangle that I drew. So let's take a quick look at how this is done in the back end. So once more, I draw an area which I want to mask out. And it tells me what to do. I forgot to select my layer. And basically, this is a map tool, which is a polygon tool, a rectangle tool, I'm sorry. So I drew a rectangle, and as soon as the sketching was complete, I came into the onSketchComplete function. And that function gives me a geometry which basically tells me where on the image I drew my rectangle. And I'm going to use that geometry to mask out pixels from my layer. So the mask raster function basically does some basic checks, such as if I have an active view, if I have a selected layer, and if that layer is a raster layer. Now, once I get all that, what I'm going to do is use the getRaster function on the raster layer to get an input raster, which represents my rendered raster. From the raster, I'm getting my raster dataset. So once I finish this section, what I'm doing is getting a raster dataset from the currently selected layer. Next up, I'm going to save a copy of it, figure out which rows and columns to mask, and then mask pixels based on the rectangle drawn. So the save section is pretty straightforward. I had a raster dataset, which I got from my last, from the layer. I now create a full raster from it. I'm going to save that out into my project folder. The save as function gives you the ability to not only specify where you want to save as by creating a system data store, file system data store, or a geodatabase data store. It also allows you to tweak the way the output is created. So one of the tweaks you can do is I can set pyramid level. So what I'm doing is I'm setting my pyramid level to 0 because I don't want to generate any pyramids, because I'm going to be changing the output after I save it out. So if I change the bottom level without changing the pyramids, then as soon as I zoom out, I won't see my changes anymore. So what I want to do when I save out my image is to make sure that no pyramids are generated. That's what the set pyramid level function is doing. The raster storage definition object has a lot of other tweaks you can do with relation to statistics and all resampling method when you're used to saving out the image, and lots of others. So once I save out to a different image in my project folder, I then open that image as a raster dataset and create a full raster from that raster dataset. So now I have a raster object ready to go to use to mask out my pixels. The get min max row column to mask basically uses the map to pixel function to map the geometry that I got in map coordinates into rows and columns. So I'm going to get min column and max column, min row and max row from the map to pixel function. I then do some checks to make sure my min and max are, my min is less than my max, and both are inside my image. So I'm making sure max column, for example, here, if it's greater than my width, I'm going to set it to my width, or I'm going to leave it as it is. So by the end of this region, I basically have my area in terms of rows and columns, which I want to mask out. Last but not least, I'm going to mask the pixels by creating a pixel block, clearing it out, and then writing it to the image in the right place. So first step, I'm going to specify which width, and I'm going to calculate the width and height of my pixel block. I'm going to use the create pixel block function on the raster. Basically, create a pixel block of the current width and height. I'm going to go through every band, which is called a plane in the pixel block, in the pixel block that I just created. I'm going to clear each band. This basically is what sets it, or make sure it's set to 0. Last but not least, I'm going to write that pixel block in the correct place, which means it's starting with the top left corner being min column and min row, which is what I calculated in the previous region. And I'm going to write this pixel block. So the area that I selected using my rectangle, I just now wrote a blank pixel block to that area. I then call the refresh function to refresh all the properties of my output raster dataset. And I am done in terms of masking my pixels. So I'm going to take my new dataset, create a new layer out of it using our layer factory.createLayer method. And last but not least, I'm going to turn the visibility off on the original layer. So basically, that's what's happening. The little bit of time it takes is because it takes a little bit of time to copy this image into my project folder. So the area that I selected is masked out. Now, one thing I did not mention was that you can handle differences in spatial reference too. Now, this image has got a different spatial reference than my map. So if I look at the spatial reference of this image, it's in UTM zone, but my map is in state plane. So basically, there is code in there to handle a difference in spatial reference between the map and the image. So the raster allows you to get its spatial reference, the map allows me to get its spatial reference. I check if the spatial reference is different. Because the raster object is an in-memory object that allows me to make changes, I'm going to set the map's spatial reference on my raster. So now when I call map to pixel and to convert my map coordinates to my pixel coordinates, it's going through the right set of reprojections, right? So the map coordinates get transformed to the raster's pixel coordinates, raster's spatial reference. The map spatial reference gets transformed to the raster spatial reference, which then gets transformed to image coordinates. So now if I select an area to mask out in this raster, once I finish, then select the layer again. So I'll start from here and end here. Once I finish, I know what's wrong. Let's do this again. So start from here, I end here. Once I finish, you'll see that the rectangle that I drew got masked out correctly. So that was basically a simple sample to illustrate how you can use the fine-grained API to access a raster dataset from the layer, create a raster out of it, save it out as a different raster dataset, and then access pixels and change pixels from it. So that basically was our samples and code on what you can do with the API. I have some information with helpful links on how you can find out more info on what we talked about. But instead of using these links, honestly speaking, the easiest way you can find more info is just type in ArcGIS Pro SDK Raster into Google. What this gives you is the first two links take you to the concepts page for raster, which gives you not only more information about the fine-grained API, such as the raster datasets, rasters, but also has links to the coarse-grained API with the layers. You can also find the second link is snippets, which are helpful snippets to write your own code. And of course, you'll find community samples as a third link, which basically allows you to look at all the samples that we have publicly available. Now, the mask raster sample we showed you is already available. You'll also find You'll also find our other sample, the change colorizer for raster layer sample, the first demo that we showed you in the map authoring folder. But the other two samples we showed you should be available inside the raster and the map authoring folder very soon as well. So I'm guessing you will have access to these slides, so you'll be able to use these links directly if needed as well. So, for a brief summary of what we talked about today, we saw some slides summarizing what's available in the ArcGIS Pro SDK when working with rasters and imagery. We saw a few code samples which illustrated the things we talked about and provided some real-world samples which can help ease your workflows with fewer clicks and easily change things or do things that you wouldn't normally be able to do. We provided some information with helpful links which can get you more information. And that's pretty much it for us. Now, the API might not have the same amount of functionality that ArcObjects API does, but that's because every feature we add to the API is A, asked for by users, and B, curated to be as easy as possible. So please fill out the feedback, not only about what you thought about our presentation, but if you want to see something in the API, you can contact us directly or you can go through the feedback as well. We'd like to hear about what you want to see, what you think is missing from the API, and we'd love to basically build it and provide it as soon as possible. So that's pretty much it for us. You guys have any questions? Yeah.
Do you guys expose the ability to adjust the sheet for the rasters? So integrate high points and shift raster and that kind of stuff?
That one's not exposed through the SDK. I believe, though, if you have the type points available, there's a geoprocessing tool that you can call through the SDK to do that. Correct.
So there's no way of creating an image and assign your geotransform to it or anything like that?
You can assign a projection to it as in terms of.
So you're assuming the image is captured in whatever projection map is and whatnot is orthorectified and all that stuff. I'm dealing with imagery that's not. I want to take crops and things like that out. I want to be able to create a new one that is using, maybe you need to shift it around a little bit.
That's basically our ortho rectification workflow, pretty much. And it's very hard to automate. Now, you're not the first one to ask that. We don't have it in the Pro SDK for sure, but even if you want to automate that workflow, it's not easy because you need a base image, usually to map it to if you're doing it automatically.
There's ways to do it.
Yes, yeah.
I'm just curious if that was exposed.
It's not. Let me go with it.
You probably said it, but you said the aspect function template example is going to be used.
Very soon.
So my other question was about the cursor. You mentioned it was the raster. Does it work with the mosaic rasters as well?
It's pretty much a raster data set in the end, so yes, it does.
Does it do like prefetching, some asynchronous prefetching? Is it more efficient to use the cursor, faster, anything like that, or manage it?
Not exactly. It's basically an easier way, so you don't have to do the calculations of where you are in the image, right? Yeah.
Okay. I'm just curious if there was any other advantage. Okay.
Yeah.
What's coming next?
We're open to ideas from you guys. Whatever you guys want next is fun. But on our own, we're thinking of maybe adding the ability to work with raster functions soon. But But yeah, anything else you guys want, please ask us and we'll try and get it done. Thank you very much, guys.